In Patagonia's ice fields, huge gaps open up in the summer months, giving scientists a chance to investigate far below the glacier's surface. Stephen Harrison is taking the opportunity to descend deep into a crevasse in the glacier. It's risky, but glaciers are melting so fast that potentially invaluable records of the past are disappearing.
This ice cap from which these glaciers flow from is melting more quickly probably than any other comparable ice mass on Earth. You can see the amount of water which is around us.
Stephen has spent the last 20 years studying glaciers and past climates. He knows that ice can preserve valuable evidence.
Wow, look at this. The colour's amazing. Carbon dioxide is an important driver of climate change. In other words, it's an important factor in changing the globe's climate. You have to see how carbon dioxide has changed with the patterns of cold periods and warm periods throughout Earth's history. You can see the ice here is absolutely full of bubbles, and the bubbles were formed when the ice was formed. And of course the bubbles contain atmosphere, oxygen and carbon dioxide. If we want to understand the role of carbon dioxide as a thermal blanket over the Earth, we need to know about how carbon dioxide has changed, the concentrations have changed in the atmosphere over hundreds of thousands of years. An analysis of bubbles such as these in places like Antarctica and Greenland gives us that fantastic record.
That record is now also preserved thousands of miles away, not in the ice fields that originally contained it, but in Denver, Colorado. In this storeroom of the United States National Ice Core Laboratory, hundreds of thousands of years' worth of ice core records are maintained at minus 36 degrees. These ice cores have been extracted from as much as 3 kilometers beneath the polar ice caps, and for Professor Mark Serres, each one provides a valuable source of information about a particular moment in the past.
Well, this particular chunk of ice is about 16,000 years old. It comes from the Greenland ice sheet. What we see here are layers of fossil snow. Every year on the top of Greenland there's an accumulation of snow, and this gets compacted year through year, layer after layer of snow, eventually to form these layers of ice. And it's within these layers of ice that we can tell all kinds of things about the Earth's past. What we find today is that the carbon dioxide concentrations in the atmosphere are higher than anything we've seen in the past 600,000 years. It's telling us that human activities are having a strong impact on the climate system. And if we measure this in parts per million of carbon dioxide in the atmosphere, what we call the pre-industrial level, before humans were starting to have an impact, was around 270, 280 parts per million. What we see now, the most recent records today are telling us that it's up to about 380 parts per million. So you can see that today's levels are far beyond anything that we've seen in the past. If you talked to me 5 years ago, I would have been kind of a fence sitter on this whole idea of greenhouse gases involved in climate change. No more. The changes that we've seen seem to be much too strong, much too radical to be just simply explained by natural climate cycles. What we're seeing now is the impact of humans. Humans are starting to change the climate itself. That's what we're seeing today.